On the previous video, ladies and gentlemen, we graphed the original parent graph of all square root functions, and it's pretty easy to do using an XY table. You plug in 0, you get out of 0. The square root of 0 is 0. The square root of 1 is 1. The square root of 2 is an ugly number. The square root of 4 is 2. The square root of 9 is 3. You get the coordinates 0, 0, 1, 1, 4, 2, 9, 3. And we see this curve that starts at 0, 0. And it's easy to talk about domain and range once you see where it starts and in what direction it's going. We also talked about on the previous video how to modify, like on this third one, we ended up plugging in 0, the square root of 0 is 0, but then minus 2 gives you a minus 2. Now ultimately we need to identify our h and k, kind of like our vertex form equations when we were dealing with parabolas. So let's jump to the notes over here. And right here it gives us the form that we need so we could clearly see our h and k values. Okay? And it tells us right here in our notes how the a value affects us. Now we already know if a is negative, it gets reflected on the x-axis. The h value is always with x inside parentheses, in this case inside the square root, and the k value is always the number at the very end that's being added or subtracted. Okay? So what we need to do to graph, the easiest thing to do, let's go back to this one that we already graphed on yesterday's worksheet on the previous video. On this guy, we graphed including the h and k, or the k in this case. What I recommend to graph all of these guys when it has an h and k is to identify your h and k. So in this case, your h value is 0 because there is no number with the x inside the square root, and the k value is negative 2. Okay? So the h is telling you that you're not moving left, you're not moving right. The k is telling you that you're going to move 2 units down. The h and k are ultimately your left and right shift. Your h is your left and right shift. Your k is your up or down shift. So what I would recommend for you guys, instead of looking at the whole function, what I recommend is for you guys to just focus in on that part of the function, ignoring h and k. Now you guys don't have to do anything on your paper, just watch me. So if I did pretend that it was just y equals the square root of x, we already know those input-output values. Plug in 0, the square root of 0 is 0. Plug in 1, the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. Now if I were to graph these coordinates 0, 0, 1, 1, 4, 2, 9, 3, that would give me 0, 0, 1, 1, 4, 2. Where's that at? 4, 2 is right there. And 9, 3. 9, 3 is right there. So those blue dots would be my original parent graph, right? Now what can you tell me about the blue dots from the original parent graph compared to my actual graph? Translated 2 down. Got shifted 2 down. Translated is a better word. So if I wanted to, the easier, or what I recommend you to do, is to graph ignoring h and k. First identify h and k, and then ignore h and k. Pretend that they're not there. Get your coordinates, plot your coordinates, and then shift them according to h and k. So these blue dots go down 2 units, down 2 units, down 2 units, down 2 units, and that's how you get the final graph. That's the easiest way to approach it. So let's move on to this one up here. Check it out. Again, I would like you to look at the function and kind of identify h and k. What's your h value? It's actually positive 1 because you're going to think opposite of what you see, right? You're going to think opposite of what you see. And the k value, that one happens to be 0. The one that's being added out here at the very end, there is no number being added outside the square root, so I would put a 0 for k. Now h being positive 1, that means I want to shift 1 to the right. K being 0, that means you're not moving up or down. you're just going to be shifting your coordinates one to the right. Now, what I recommend is for you to ignore h and k after identifying h and k. And just make an xy table for these guys. So your xy table for the above function without the h and k, the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2. Let me zoom out a little. And of course, the square root of 9 is 3. So let's graph those coordinates 0, 0, 1, 1, 4, 2, 9, 3. So if I graph those coordinates 0, 0, 1, 1, 4, 2, 9, 3, we end up with this parent graph curve, but that's not the curve that I want. I want the curve including the h. So what I'm going to do is simply take all of those dots and shift them according to h and k. And this is telling me to shift them one to the right. So if I take every one of these coordinates and move them 1 unit over, I'll end up with my actual points right here, this one right here, this one over here, this one right there. And now I could actually graph those finalized coordinates according to the blue dots. Does that make sense? Okay, so the easiest way to go about this is to identify h and k, ignore h and k, make a table of values, and then translate your coordinates according to h and k. Check this guy out. It has both an h and a k. Let me do that. Let me go h equals what? Negative 2. That means I'm going to end up moving 2 to the left. And the k value is what? Negative 3. That means I'm going to end up moving 3 down. So the way to do this would be, again, to just ignore, after you already identified h and k, just ignore h and k and look at that part of the graph. Okay? So that would be, if we go to an xy table, let me zoom out. XY table. The square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. Those are great coordinates that are from the parent graph. So if I plot those points, so if we plot the coordinates of the parent graph, we end up with these coordinates, that same parent graph curve. But of course, I'm not going to draw a line through it because that's not my final graph. My final graph is going to be taking these coordinates and moving them 2 to the left and 3 down, each and every one of them. Okay? So check it out. I want to focus in on these dots, and I want to move them all 2 to the left and 3 down. So if I take this original one, move it 2 to the left and 1, 2, 3 down, I end up right there. Okay? I'm going to put this in blue. Now, the next one, if I move it 2 to the left and 3 down, it's going to be right there. The next one, if I move it 2 to the left and 1, 2, 3 down, it'll be right there. And the last one, 2 to the left and 1, 2, 3 down, it'll be right there on the x-axis. Whoops, should have done that in blue. So where's our actual graph? It's here with an arrow right there. So let me zoom out of here so it'll be, whoops, sorry. So let me walk you through it once again. We identified h, negative 2, k, negative 3. That means 2 to the left and 3 down. And then we ignored h and k. So if you ignore h and k, you're going to get your coordinates of your parent graph. And then after you get those coordinates and plot them right there, those red dots, you simply shift them all according to h and k. And h is negative 2 and k is negative 3. And once again, I want to remind you guys that you have to think opposite on h. Whatever's inside parentheses with x, you have to think opposite. And the k, whatever number's out here, you take it for what it is. Now, if you look down here at our notes, that explains why we have to think opposite on h. We think opposite on h because it says minus h, and the minus sign is truly telling you to think opposite. The plus k is telling you to take k for what it is. Now, this shouldn't really be that shocking or that, it should be familiar to you because we've already done parabolas in vertex form. You guys remember y equals a parentheses x minus h squared plus k? You guys remember that? That was from graphing parabolas. And we were able to find the most important point of a parabola by identifying h and k. H and k was our vertex. That was the most important point. and you had to think opposite on h, and you took k for what it is back when we found the vertex of a parabola. Same thing here. The h is inside parentheses with x. Even though there's no parentheses, there's a square root, and h is inside that square root, kind of like if it were parentheses with an x, and you have to think opposite on h, and you take k for what it is. And just like vertexes of parabolas, the h and k is the most important point of a square root function because it's the point where it begins, right? That beginning point is the most important point of a square root function because that's what you're going to use when you identify domain and range. As a matter of fact, I forgot to mention that. Let's go back to the graphs. Let's go back to these graphs up here. We didn't talk about domain and range, but if we know our h and k, it's easy to talk about domain and range. Our hk value, our most important value here, is the coordinate 1, 0. That's the most important point, which is this guy right here, 1, 0. So when we talk about domain are our x values. So let's talk about domain. The domain are your x values. Now your x is going left and right. Is this graph, does it have any points on the negatives on the x? There's nothing going to the left, right? It's all going to the right. Nothing going to the left, all going to the right. Now, in terms of your x values, these guys are negative, these guys are positive and growing. So where does this graph actually begin in terms of x's? At 1, and it's greater than 1. So the domain is going to be x's greater than or equal to 1. Does that make sense? Okay, now let's talk about range, because we're going to have to do this on Friday's quiz also. Range are your y values. Now, y values are going up, right? This is a y value of 1, y value of 2, 3, 4, 5. Here's a y value of -1, -2, -3, -4. Does this graph have any y's in the negative? No. Where does it start at? The y value of what? 0. And does it go up or down? It goes up. So that's greater than or equal to 0. That's right. That's the domain and range. So domain and range is really easy, especially when you identify your most important point, hk. The hk value, just like on parabolas, the hk value was the most important because that was your vertex. Right here, hk is the most important because that's where your graph begins. Let's take a look at this next one down here. We already graphed it. We know our h and k value. That hk value, the most important point, is -2, -3, correct? No, I'm sorry. Yeah, it is -2, -3. That's the most important point of this square root function. So let's talk about domain and range with regards to that most important point. So the domain would be all of your x values, but where's this graph at? Is it less than or is it greater than a certain value? It's greater than or equal to -2. That's a domain. How about the range? The range are your y values, and the y values are either going up or down. Now, we could clearly see that there are no y values down here. The graph doesn't exist down here at -9 or at -8 or at -7. The graph exists right here. Where's this value at in terms of y? -3. And it exists above or below -3? Above. So what do we say? Y is what compared to -3? Greater than or equal to -3. And that's the domain and range. So once again, guys, the trick, the easiest way to tackle these graphing problems of radicals is to identify your h and k, ignore h and k, and just focus in on the parent graph, make an xy table for it, plot the points, and then move your points according to h and k, and that's how you get your finalized graph. Once you have your finalized graph, then you could talk about domain and range, especially because you know your hk value, which is the beginning of that graph shooting off in one direction.